So over to our right here, we have our properties panel, and our properties panel will display relative information to the object we have selected. But to the far right over here, we have this little blue whoosh icon, which is representing a ball hitting the ground and bouncing. And this is our physics tab. Now, just by looking at the titles of each of these buttons, it's not too difficult to figure out what all these different physics properties we can apply to our selected object do. However, it can be a bit more difficult to actually get them to work in the way that you expect them to work. So we're going to save going over most of these for another video. But first thing to understand about adding any of these physics properties is that you're only going to see the effects of these different properties you add whenever you play back your actual animations. Basically, pressing play is like starting the physics simulation itself. Out of all the cool physics properties we can add to our objects, the rigid body set has so many options and cool things we can do with it that we actually have a menu devoted entirely to it in our tool shelf. So over here, if we press T and click on physics control, this menu is devoted to rigid body physics here. So if I manually add the rigid body physics over here in my physics tab with my cube selected here, if I press rigid body, you'll see I get 3 new menus. I get this rigid body here, rigid body collisions, and rigid body dynamics. And as you can see, there's quite a bit of options and settings and things you can change here. And actually, depending on what you have chosen for some of these settings, you'll actually get further settings to customize. So the point of this physics control menu is, one, to give you quick access to these options, whether you're in full screen or whether you are, dealing with modifiers. And the other big part of this is that it contextualizes a lot of tasks to help ensure that the buttons you press do the things that you want them to do, basically. So I'm showing you these menus right now so that you're aware. Most of these buttons will be manipulating these settings, but in some instances, a few other things to make sure that stuff works the way it's supposed to. But if you need to get, more tight control on something, you can always come over here to the physics tab and check out these rigid body options here. So you can, of course, get rid of any physics property you add to an object by clicking the little X on it. Notice that the cube is now highlighted in green because when we press rigid body, it added it to a group, and I'll show you what I'm talking about in a minute. But if we click X, it will go back to being highlighted in orange, and you'll see some of these settings have now been grayed out in this menu because they're not available unless rigid body physics is being used. So there are 2 basic types of rigid body physics: active and passive. If I were to, instead of directly adding rigid body physics via this menu over here, I could actually be on any tab and press add active here. Then that would add the active type of rigid body physics. Both the passive and the active type will give your object collision physics, basically meaning that anything else belonging to this rigid body world group that's highlighted in green here will be able to touch it and affect it. The active type also gives gravity to that object, whereas passive will just lock it in 3D space. So we pressed add active, and if I click over here on my physics tab, we can see that the rigid body physics were added when we press add active. And actually, if I click under rigid body here, you'll see that the type is of active. If we now press play, like we talked about, if we want to see the effects of any of these physics properties, we have to press play to start the simulation. We'll see the cube is now falling faster and faster into oblivion. So I'll pause and go back here to the beginning, and you'll see that everything goes back to where it was. Or if I right click on my timeline and just drag my timeline back and forth, you can see I can sort of scrub through this physics simulation that we started. But notice right now, if I press G to grab, middle mouse to constrain, and bring this cube up here, and there's my 3D cursor in the center, and I were to say press Shift A, and under mesh, add a plane, press S to scale. Say I didn't add any kind of physics to this plane, it's just a regular plane here, highlighted in orange, and I were to press play. Notice that the cube goes straight through the plane, and that's because only other objects that have been designated for this rigid body simulation are going to affect each other at all. So if I come down here in my outliner and I right click and I press view groups, you'll see this group here, rigid body world. And if I were to press X here to remove rigid body physics from this cube, notice that that group goes away. So whenever we press add active or add rigid body physics via the menu over here, which I don't suggest doing, it's a lot easier to just press add active or add passive on an object, a rigid body world group is created. So if I click the plus sign, we can see that this cube here has now become a part of this rigid body world group. I can actually press play here right in the physics control menu, and this does exactly the same thing as pressing play down here, only it's a nice little quick way to get to that when you're making adjustments in this menu or when you're in full screen mode. So if I were to click on this plane and then press add active to it, notice down here in our rigid body world group here that now this plane is also a part of this group. So if I shift select both of them, you can see they're both selected. They're both highlighted in green here, which of course that's the mnemonic for green group. Basically, whenever you see something highlighted in green, it means it's a part of a group. If I press play now they're both falling to oblivion, which is not really what I want. To keep an object a part of this rigid body physics simulation, but also lock it into 3D space and remove the effect of gravity on it, we can press add passive to add passive rigid body physics. So now if I press play, the cube falls and hits the plane as though it is landing on the ground. Okay, so we went really slow through this because I wanted you to understand both about this physics tab we have in the properties and really what's going on with these rigid body physics. And I'm going to go ahead and right click and press go back here to get to my regular outliner view. But really doing what I just did, we can do in about 10 seconds. So if I were to press A to select everything, press X to delete, and I'll go ahead and press back here. So I could press Shift A, under mesh, add a cube, G to grab, middle mouse to constrain, press add active, Shift A, and under mesh, add a plane, S to scale, press add passive, press play, and we're using rigid body physics. So it's actually really easy to immediately get this physics simulation going in your scene. I'm going to go ahead and under my builder options, turn on high def shading so we have a little nicer environment to work with here. So we can add any objects we want to this little simulation. I could double right click over here, add a torus shape, maybe tap W a few times, S to scale, and I could press add active on it. So if I press play now, which of course these buttons do the same as the ones down here, just a little quicker way to get to them. We'll see that fall and those hit the ground. So we can add new objects, or we can simply duplicate objects and their physics properties will be copied, which is nice. So I could press D to duplicate this a bunch of times, press play, and you see they all land on each other and fall on each other. Another really cool thing about this physics simulation here is that you can actually pick objects up live while it's going on and interact with them in real time, which is super cool. So you notice that the timeline just hit the end of the animation. So this animation set up to be from 0 to 600 frames, which is about 20 seconds because we're at 30 frames per second here. And so the simulation actually starts over once the timeline gets to the end, but we could pause this, go back, and we could actually make this as long as we want while we're playing around with this physics simulation. So I could change this from say 600 to 10,000, I guess, or whatever you wanted. And that way the simulation would just keep going on basically as long as you wanted it to, which is cool. And so we can click and grab and pick up objects alive in the 3D view, which is totally sweet. Press pause here, go back. So we could say, select this floor here, press D to duplicate, middle mouse to constrain, S to scale this down, maybe move this over or scale it out or something. And of course, this is using passive rigid body physics, so it's just going to stay locked in space, sort of like maybe a 3D platformer game where something like that would exist that shouldn't really in real life. Or we could go back, I could press tab to go into edit mode, E to extrude, and adjust this mesh here, create something for these maybe to get hung up on, who knows, something like that, and press play again, and they'll just fall off of here. Of course, we can pick all these objects up. I could actually select the ground here, press R to rotate, and just shake up the whole world here if I wanted to, which is pretty cool. Press pause, go back, press Control Z a few times to undo those rotations to the floor there. And so right now we're dealing with a really simple simulation, only a couple objects here. So Blender isn't really having any trouble calculating these simulations in real time. But when you get to having more and more advanced simulations, you've got a lot of objects, you've got a lot of physics and things going on. Occasionally when you press back here or back here in the main timeline, everything might not get reset how it's supposed to. If that ever happens, you can press this free all button, which resets all the baked physics simulation cache in the live 3D view, or if we were to actually bake the entire physics simulation. And what baking the simulation means is basically when we press play here, Blender has to figure out in real time how these objects should react in relationship to all the other objects belonging to this rigid body world group that the simulation is set up for. And so if I were to press left on my keyboard and just go back frame by frame by frame here, well, I have to move the timeline down a little bit because all the objects had already stopped. But if we were to just press left keyboard to go back, you can see what really composes this simulation here is a bunch of generated frames. So once Blender has had time to bake the simulation, crunch all the numbers as it were, it knows where to position all of the objects rather than having to figure out where they go and then position them. If the simulation ever gets messed up, you can always just press free all and go back and you press play again, and then it will recalculate or recrunch all the numbers. It normally does that on its own anyway, but if it ever doesn't, just know that that free all button is there. Of course, we can use this handy remove button here to remove any object we want from the simulation. So if I press back to go back here, say I don't want this particular torus shape to be a part of the simulation, I could just press remove, and that will do the same thing as if you press the remove button here under the physics tab property. So remember once again that this physics tab in the properties panel, this is telling us about what's going on with each selected object. So if I click on this object, we see all of its settings. I click on this object, we see all of its settings, and so on. With this one removed, now it's highlighted in orange again, meaning that it's not part of any particular group. And I press play, it'll just slide straight through it as though it were a ghost. Press pause, go back. So that's a basic introduction to rigid body physics. In the next video, we'll discuss how to set an object's center of gravity and these collision settings here. We'll also get into using rigid body constraints, which allows us to do a lot of super